Hey guys, I'm David from Formula Trinity Autonomous, and this is going to be a tutorial on how to use our F1TENTH Quickstart repo. So this repo is a fork of the F1TENTH gym, and we've designed it hopefully to be as lightweight and easy to use as possible. If you need a reference for this tutorial video, pretty much everything I go through is in the README in our repo. Okay, so the starting point for this tutorial is we're just going to open up our repository on GitHub. So the link for this repo will be in the description. So let's see what other prerequisites we have. Okay, so Python, you need to have Python installed, that's a requirement. And then we also recommend you use Visual Studio Code as your code editor and also to use Git. Now, basically we've chosen Visual Studio Code just because if you've never used a code editor before, it's a good place to start. If you usually use other code editors, that's fine. You can use them. With regards to Git, basically if you're not familiar with Git, it will allow you to easily get all the latest changes we make to this repo if we make any changes. But if you want, you can actually click here and you can download the whole repository as a zip file. And that's just for if you've never used Git before and you're not really bothered learning how to use it and you're not bothered installing it. But yeah, in this tutorial, we're going to go ahead and use Git and Visual Studio Code. So let me open VS Code. All right, so just as part of the demonstration, we're going to go ahead and open up the folder of wherever we want the repo to end up. So basically, we're going to clone the repo now, which means we're basically going to download the folder. So I'm going to say git clone, and then back on GitHub, if you click here, you can copy the link we need. So you copy it in there, git clone, and the link to the repository. And then as you can see, this folder has been cloned into our local computer. Okay, so now I'm going to switch, because we don't want to use this our kind of bigger folder. Now we want to just open up the repository that we've just cloned in. Okay. So yeah, you might not have a terminal down here. All you have to do is go ahead and click new terminal if there's ever not a terminal down here. Okay, so back on the repo page with the instructions, it gives us this pip install command to use. Now, if you're unfamiliar with pip, it's fine. If you have installed Python, then you should have pip as well. Basically, all it is the package manager for Python. So this command is going to install all the packages that are required for this project. And for me, because I've run this command before, as you can see, it's coming up requirement already satisfied for most of the things. And for you, it might take a few minutes, and that's fine. Okay, so now we're kind of at the point you would be anytime you go to work on your project from now on. So I'm actually just going to, rather than stay in the whole repo, we're actually only going to be using the files in this source folder. So just because this is kind of what you're going to be doing every time after you initially clone it, I'm going to open up the source folder instead as our kind of main folder. So I'll just open a terminal again. Okay, so as you can see here, if you're not super familiar with the terminal, it just shows where we currently are. So this terminal is basically currently in the source directory. So straight away, let's go ahead and just run the simulator. So you say Python and simulator.py. So the first time you run it, it might take a few seconds to run up, and that's fine. Also, because I'm I have a few things running in the background like OBS. It takes a little bit longer, but you'll experience that yourself, that the simulator might be slower if you have things running in the background. That's actually fine. Although it's slightly inconvenient, you can actually still know how fast your car is. Because if you look down here, you can see these seconds aren't actually every second, evidently. So you can still see how fast your car is actually going, because by the time it gets to the end, you'll see what your lap time is. Okay, so this car is doing pretty well to get around the track. So at the beginning, you're already given a car that's decent enough as a kind of starting point, if you want to use it. Okay, so let's take a look at what is in this simulator. Okay, so in the simulator file, there's all this stuff down the bottom. You don't need to worry about it. This is basically just handling all the stuff to do with getting the input for each car and getting the commands from each car, etc. All we're going to be worrying about while we're developing our project is this section here. So as you can see, you import your drivers here, you choose your drivers here, and then you choose your racetrack here. So, okay, we've got these drivers. We've imported a couple of drivers here, gap follower and simple driver. Let's just switch driver now. Okay, so this is basically how you just choose a different driver. Now the notation here might be a little confusing. Basically, it's a list of drivers. That's why we have these brackets here, because we can have 1 to 4 drivers. Now, any more than 2 drivers, you'll probably find that the simulator is too slow, which is fine because in our competition, we're only going to be racing 2 drivers. But if you ever want to see how 4 of your drivers perform alongside each other, then you can go ahead and mess around with this. But it's recommended just to use 1 or 2 drivers. So let's see what the difference is with this simple driver. Again, let's run it down here. Okay, so what does this one do? All right, so it just crashes into the wall, so that's not great. And so let's open up. Okay, so imported simple driver from starting point. Okay, so we got this starting point file over here. Okay, so this is the most basic version of a driver you can have. It's just a class, and it implements this process LiDAR function, which takes in a list of LiDAR ranges, which is basically just the distance that each LiDAR ray has detected, and then it returns a speed and a steering angle. Now, as we just saw, the simple driver just was pretty simple and went straight ahead into the wall, which, as we can see, we know why now, because it has a steering angle of 0, meaning straight ahead, and it goes at a speed of 5. So basically, it doesn't do any calculations as to what's going on. So then, well, that's not great because it's not very smart. So then a slight step up in complexity would be, for example, to drive towards the furthest point you see. So this code might seem a little daunting at the beginning. We got all this strange stuff and mathematics. If you're not super familiar with Python, it might seem daunting, but it's actually, if you just think about this a little bit, you'll probably be able to make sense of it. So, all right, let's see how much better this another driver is. So, how do we import another driver? Here we go. Because it's from the same starting point file, we just say import simple driver, and then we can import another driver again. And we could get rid of simple driver altogether. So let's switch this to another driver. Save it and run it again. Remember, this is going towards just the furthest point it sees. Okay, so yeah, it's not great either because it goes towards the furthest point, but actually the furthest point is right next to the corner. So it's not taking into account, the width of the car or anything like that. So you can see already we've stepped up in complexity, but already there's more things you have to think about. So, okay, so we got our drivers. So these are the simple drivers, and then so these are kind of just a starting point, so you can try familiarize yourself with how to process LiDAR, etc. And then let's have a look at what the gap follower driver was that performed so successfully at the beginning. So this is a big file because there's lots of functions going on here, but you have to remember that all a driver is it's a class which has a function called process LiDAR that takes in the LiDAR data and returns the speed and the steering angle. So obviously there's lots more code to this because this process LiDAR function actually calls the rest of these functions so that it can process the LiDAR effectively and come up with a good speed and steering angle. Now with regards to this specific driver, it's using the follow the gap method, which you can research yourself and see how it works. Okay, so we've seen a few different drivers now. Let's just test out using more than one driver. So I can choose gap follower and I'll choose simple driver. Okay, so as you can see, it's a list of just 2 drivers, and that's all we need to do to choose multiple drivers. Okay, so as you can see, the simulator is running pretty slow because we have 2 drivers and I've got this stuff running in the background. So as you can see, simple driver doesn't stand much of a chance. So it's not the most exciting race, but yeah, that's how you would have multiple drivers racing against each other. Okay, so finally, let's just show you how to use different tracks. So as you can see here, we have been using track 1, and we can choose any of these. So actually, where are these tracks stored? Over here in this maps folder. So we can click on any of these images and have a look at the different tracks. So we've got 3 tracks that are kind of standard, just clear racing tracks, and then we also have an obstacles track, which, as you can imagine, has a lot of obstacles on it, because that's one stage of our competition is to be able to move around obstacles. So this is a good track that kind of moves up in complexity as you drive through it. So let's actually switch to using the obstacles. So all we have to do is change this to say obstacles, and let's go again. We're just using gap follower on this new obstacles track, and we'll see how it performs. Okay, and by the way, to zoom out, you just use the scroll wheel on your mouse. Okay, so as you can see, there's lots of obstacles on this track, and the gap follower does a pretty good job on it. So yeah, that's about it for the F1TENTH Quickstart gym. So yeah, I'm really looking forward to seeing what you guys do with this, and also if you have any changes you'd like to make, it's still during development. So as you can see, the gap follower, it's good, but it's not that good. And you'll find that if you pitch 2 gap followers against each other, that the gap follower isn't great at multi-agent racing either. So yeah, one starting point for you could be to try and improve this gap follower, and we've actually put these kind of parameters at the start so you can mess around with these and kind of see what effect it has on the algorithm. Now, this won't make much sense to you. You see bubble radius. If you actually research what the follow the gap method is, then this stuff should start to make sense. So yeah, that's about it for this tutorial, and I'm really looking forward to seeing what you guys come up with.